Okay, let's see if we can use what we learned about imaginary numbers in the last video to go back to square roots and simplify something that looks like this. The square root of a negative number. So we know that with real numbers, that is impossible. There is no real number that is the square root of -2. You cannot have any number that, when multiplied by itself, equals a negative number. But we can use imaginary numbers, more specifically I, in order to simplify this. So what do we remember about square roots? Well, we know we can break up the number inside the square root into two numbers in order to simplify this. So let's change the -2 to a +2. And then in order to get back to -2, we'll have to have 2 times -1. So the square root of -2, all we did is break it up into 2 times -1. And now we know that with square roots, when you have a square root of two numbers being multiplied, those can be broken up into separate square roots like that. And now look what we have here. The square root of 2 times the square root of -1. And we know the square root of -1 is I. So this will equal I times the square root of 2. So using I, we can simplify square roots of negative numbers. And that's what we're going to be doing in this video. So the square root of -7. Well, we know that this can break up into the square root of 7 times -1, which will be the square root of 7 times the square root of -1. And since the square root of -1 is I, this will be I times the square root of 7. Okay, pretty simple. Square root of -16, this will be the square root of 16 times the square root of -1. Now, what do we know about the square root of 16? We know that that is 4. So this will be 4 times the square root of -1, or 4i. The square root of -20. This will be square root of 20 times I. And what do we know about the square root of 20? That can be broken apart into square root of 4 times square root of 5. Simplify square root of 4 to 2, and we get 2. We get square root of 20 is 2 times the square root of 5 times I. And we're going to put the I right there before the square root. That is the neatest looking way to write that. Okay, let's make it a little more challenging. 3 times the square root of -48. First, just keep the 3 out here and ignore it for now. What is the square root of -48? Well, it's going to be square root of 48 times I. Square root of 48, we're going to have to break that up. So if the first perfect square you thought to use was 4, think again, because it'll be much easier if we use the higher perfect square of 16. Square root of 16 times square root of 3, which will become 4 times the square root of 3. And since it's -48, it will become 4i times the square root of 3. Now just multiply the 3 back in that we left outside, and we'll get 12i times the square root of 3. All right, let's bring in a fraction. Negative square root of 60 over 4. So, leave the negative outside, break up the square root of 60. We can use 4 as a perfect square, so this will be square root of 4 times square root of 15 is 2 square root of 15 over 4. And then remember that when you have numbers here that can be divided, you need to do that. So we're going to divide the numerator and denominator by 2, and we'll get negative square root of 15 over 2. So the reason there's no I in this problem, there's no imaginary numbers, is because the negative was not inside the square root. It was outside of it. You'll only need imaginary numbers if you're taking the square root of a negative number. This is a real number. Okay, for this one, we do have a negative number inside a square root, so we will need to use I. So again, leave the 5 on the outside for now. Square root of 32 times I is what this will be. We'll break up square root of 32 into square root of 16, square root of 2, which will be 4 square root of 2. And don't forget the I over 8. Now let's see if we can simplify this in one step. 5 times 4 will make 20 here, and then we'll divide the numerator and denominator. 20 over 8 will simplify to 5 over 2. So this will be 5 I square root of 2 over 2. And let's do one more. So square root of 112 times I. So square root of 112. Well, we can see that 4 would work, but if we use 4 as a perfect square, this is going to take a really long time to simplify the square root. So let's try some higher perfect squares to see if they work. Does 9 divide into 112? Well, 9 times 10 will be 90. If you keep adding 9, you'll get 99, 108, 117, and we skipped over it, so 9 will not work. How about 16? 16 times 6 will be 96. Add another 16, and you will get to 112. So 16 times 7 is 112. So the square root of negative 112 will be the square root of 16 times the square root of 7 times I. And since the square root of 16 is 4, this will be 6 times 6 from out here, 4I times the square root of 7. And then again, we just have to multiply the 6 here. 6 times 4 will be 24, and then we'll have 24 over 20, which will be 6 over 5. So we'll be left with 6I square root of 7 over 5. Okay, and we are finished with square roots and imaginary numbers, or at least learning them for the first time. We will be using them quite a bit in the future videos when we start tackling quadratic equations in the next video.